Welcome to the Crazy Wisdom Podcast. My guest is Matt Parlmer. He is the founder of General Fabrication, and they help people build fabs. And the first question is, what is a fab?
A fab is a production facility that's, not necessarily smaller than a factory, but organized around fundamental building blocks that are a lot different than today's machines, primarily small and expensive commodity robotics.
That's so cool. And so what is, so when you say factory, I think big, and you're in Michigan, which is fascinating because I think of a big factory with thousands of people going into it, but that's not what you're talking about, is it?
Well, the factories of the future are going to take on as many forms as the industry of the future, right? Like, we have so many different processes and technologies coming down the pike with different economies of scale that there will always be like heavy industry, like the steel mills will always be in relative terms much larger than somewhere that's making Game Boys or something like that. So, there's this like gradient of industrial and capital concentration. But we think that the sort of curvature of that is changing a little bit in the near future. Mainly just because of, the 3D printing revolution has finally made it economical to engage in serial production of high value, low widget count products. But we think that we're going to likely go several steps beyond that in terms of what's possible at the scale of 100 machines in a warehouse somewhere. And the way that that's going to happen is likely going to be through the introduction of different like low force processes that can run on these very cheap commodity tooling systems, robotic tooling systems.
And you mentioned widgets. Okay, so there's a whole bunch there, and I don't know enough to quickly synthesize all this. But so widgets, serial production of widgets, and that serial production means basically like I have a 3D printing, or I have like several 3D printings that are all specialized to whatever thing I'm building, and I can just pump out a lot of them in my home area, basically.
Continuously, yeah. So what's neat about this is so what?
Yeah, continuously. That was interesting. I should go for it.
Yeah. So you can a lot of industrial production happens at like job shops or contract manufacturers, and the reason that happens is because what you end up having to do is organize a lot of people, or a lot of special purpose machines that you have to timeshare on computer, and you have to organize that sort of thing at a certain scale to allow for the economical use of that of that large big iron resource. And what we see happening across a lot of different fields, but now in manufacturing robotics, is the reduction in it is a pretty substantial reduction in the cost for things like 3D printers and the cost for other things that that can make stuff with relatively high precision at low capital density. That is what we think is interesting about. There's been a lot of rumblings lately about Moore's law for everything, and we think a particular area that's about to get caught up in that.
Okay,
in that sort of that sort of.
And something that came to mind.
So basically, what this allows, though, is that people, what this is enabling is the $10,000 OmniFab. Essentially, is the end end result of a lot of this stuff.
Okay, $10,000 OmniFab. To those of my listeners who don't understand what that means, basically, it's you can have one machine, or one. It's not even one machine, but it's just like one generalized factory that can create a whole bunch of different stuff, or is it still creating
a collection of Lego bricks? Yes.
Okay. And so this is the
Well,
thing.
the idea is to eventually get these things. Sorry, say what?
Go for it. I think we're having a time delay, so I think there's some sort of issue, but I want to continue going into it.
Oh, okay. All right. Yeah, that must be it. So yeah, we take a lot of inspiration from John von Neumann's concept of the universal constructor, right? Like a machine that can replicate itself, because obviously that's useful, for things like space probes or strip mining asteroids or what have you. But it's also really useful, here on Earth to, create a lot of material abundance for a lot of people. And the way that we think that that's going to be enabled is by lowering the bar of access to machines that can make other machines by quite a lot. And we're not going to be able to do semiconductors in a sub $10,000 OmniFab, but you're definitely going to be able to do things like circuits. You're definitely going to be able to do things like, electrochemical machining. You're going to have access to all manner of different like small furnaces. So this essentially means that if you're making any sort of object that is smaller than roughly, a meter cube, in not very many years, it's extremely likely that, all of the machines you would really need to make more machines will fit into some sort of, ISO container like object that can just be dropped somewhere.
Whoa. Okay. Interesting. So it's like a shipping container factory OmniFab that you can place anywhere.
And that's I want to be clear that that's not necessarily that's not necessarily what we're selling to people right now, but we're going to be making things that sort of asymptotically approach that.
And so I guess this is a good time to go into my particular interest in this is that homesteading. So I'm going to go through a list of things.
Right. This is, that's sort of why I mentioned that angle of it.
So I'm going to go through a list of things that need to be done in my homestead over the next thing. So I've got a garden. Most of the things will have to do with gardening, and that has to do with a lot of lumber. There's also soil, and that seems more organic, which I'd love to understand more. Probably that's more of in the future kind of thing of like what kind of things can you print organically or manufacture organically.
We have biodegradable plastics.
Interesting.
Lots and lots of biodegradable plastic filaments already very widely used across the market.
Whoa. And so I'm thinking, and so maybe I could even get myself off of lumber, which is good right now because lumber itself is starting to get crazy supply chain issues. So are you telling me that I could go build a garden box out of biodegradable plastic?
That would require a substantially larger printer than what we typically would use. But if you had a bunch of MDF boards, you could easily print corners, for example. Or you could get off of soil type agriculture entirely. I actually have an on again, off again crack key pot based onion farm that I run that I 3D print most of the components for.
And that's just off of soil. So you're now into vertical gardening. Is that?
Yeah. So this was solving my so the onions that they had at the store directly across from my apartment in Chicago during the height of COVID lockdowns, they had very low quality produce. So I ended up having to schlep all the way out to go grab some high quality produce from a market that was still open. Some ways away. And then I schlepped all the way back and I was like, all right, well, I have all these great onions. How do I get more onions without having to schlep through, COVID infested wasteland? I ended up doing a fairly sizable onion grow, and the 3D printer was absolutely essential in that effort.
It is so interesting because the fad of 3D printing was so strong. The economists got on it. like 10 years ago, and it was so strong, and then it's basically been silent for the last 4 or 5 years.
Yep.
And so, but now what you're telling me, so what, okay, this is a better question for me getting started, because I basically just need to learn the skills that allow me to see the world in the same way that you see the world, which is, how do I grow this thing? How do I build this thing so that I can grow this thing? What is the main skill? What's the main blocker that you can tell that I have right now to understanding how to switch my mindset?
I don't necessarily think I can identify a blocker. I think that there's not necessarily a mindset change that needs to happen around some of this stuff. I think that really, if you just explain the straightforward economics of what's happening in commodity robotics, people kind of intuitively get it.
Well,
does that make sense?
There's some sort of, but there's some sort of thing that, from my understanding, in order to 3D print something, and I've never 3D printed anything, so I need to develop a CAD model or download a CAD model that somebody else has created, and then get the plastic that I need to put in the machine, and then it'll create this little figure. So what about that model is wrong? Or that is exactly what's happening. But the thing that has changed is that basically every step of the process is going to be industrialized. But in small enough packages, the way I've analogized it to people is this is the big iron to commodity server transition in manufacturing equipment. So back in the day, go for it.
Sorry?
Yeah, go for it. Explain iron to commodity. I didn't understand iron to commodity.
Yeah, so big iron. So big iron is a term, a computer industry term of art for, for large like IBM Z machines or Crays. Like the very aesthetic mid-century modern supercomputers that you see people posting Twitters or photos of on Twitter. That sort of stuff. Lots of memory tapes, and these things are the size of rooms. And that for a very long time was a computer, right? Then the 1980s came around, desktops became a thing, and we transitioned most of our computing from from big iron, like large concentrated machines, down to desktop computing and using the communication system to move information around, via email and other things like that. That exact same revolution is happening in manufacturing. So we still have big iron, we still have big machines, there always will be huge server farms, right? But there's also this new market for mid-size or small clusters of fabrication equipment, because what those will allow are totally new business models that that couldn't previously exist when what you needed to say machine a block of aluminum was like a $50,000 Haas mill, right? Or significantly more expensive. In like probably around 18 months, there will be products hitting the market for probably around $2,500 to $1,500 that'll be able to do almost all of the things that a Haas does, but electrochemically without many forces. And when you can do something electrochemically and without many significant forces, and you can do it in a nice, well-contained solvent bath, which is how electrochemical machining usually is done, that allows you to scale down the heaviness of the piece of equipment, and therefore you can have a lot more of it. So imagine having the capabilities of extremely high performance machine tools just scaled way down, to something roughly a meter on the side.
Okay.
The implications of it, are that most of the built environment is going to change, but what we're trying to get people to think about right now is how they could change the built environment given that set of systems.
Yeah. So the constraints are changing. So there's
yes.
And the computer is basically, there's an analogy made with the computer, but it seems like it's happening. It's like it's like meta, because so the computer allowed us to take information and take knowledge and basically compute it and numbers and all these different things. And so now something new is happening where the very nature of our physical surroundings can be manipulated using both a computer and the manufacturing, so that the manufacturing no longer needs to happen in some sort of large thing that's dedicated to this economic activity that needs to, like, that's very fragile. It can now be essentially decentralized and in smaller. It sounds like it's not to the point where I can go get a printer right now and start fixing all of my problems. I still am stuck on this larger supply chain. So I guess that's a question. How will this affect the supply chain, which has been recently kind of had to be retooled and is still not been able to figure out what has happened since COVID? How will this affect that?
So in the long run, so in the short run, this means that in addition to all of the stuff that you move around, you'll likely start moving around a lot of filament and potentially a lot less like random plastic. With tools this inexpensive, it becomes economical for you to just have optionality over the form that a bunch of plastic that you're holding on to is going to take. So I expect to see a lot of people sort of like forward storing lots and lots and lots of filament and other like raw materials that plug into these processes. Eventually stock aluminum is going to be something that you're going to be able to pick up at like a hardware store, right? So that's how the supply chain is going to change in the relatively near future, like in the next 3 to 5 years. I think in the 10 to 30 year range, that's when you start to see like truly profound shifts, because at that point the economics will sort of like direct from producer and close to consumer manufacturing. Eventually those economics will be sort of self-evidently better than most of what we do right now for most products. And I expect that then to change supply chains almost entirely. You're still going to have a lot of stuff that moves around by the air. Any sort of thing that we're going to want quickly will be air mailable, and then everything else is going to just be raw materials moving through bulk transit.
And then, so going back to me,
really weird.
Going back to the problems that I will face soon is so with me, if I buy a rep wrap 3D printer or whatever you guys are creating, that could be a Homesteader or whatever. What can I print? What are some examples of things that I might need in the garden or in the house that I could print immediately once I have the filament? Because when one of those, you're just taking plastic filament and then creating shapes, right? Sure.
Yeah. Well, do you so in the home or in the garden, I mean, there are a lot of things that if you take sort of a traditionalist approach to them, whether it's gardening or whether it's building a home or other things like that, you're just not going to need a lot of plastic. And in that sort of circumstance, you can go print things that are that are plastic that you would otherwise hook into a larger supply chain for, but typically those things will be a little bit more durable. So stuff for babies is something that comes to mind. I mean, there's so much random plastic junk that comes along with early child rearing activities. There's all manner of kitchen implements, any sort of specialty tool or jig you need for woodworking, any sort of jigs in particular, like anyone who's in a homesteading context doing a lot of woodworking, doing a lot of stuff like that, you want one of these just to make jigs. Like that, in fact, you should get a dedicated jig machine, and then get like 4 or 5 other machines doing other things around the house.
Okay, got it. So here's something else that's kind of clearing in my is that there's I need one machine okay, so the question is how many at a consumer level, how many different machines are there that a normal, like not too specialized person could have in order to improve their lives?
I think most people are going to end up over the 10, 15 year time frame having probably like 2 of these in their house.
Okay, interesting. But for the more
I think of it as roughly in 3 to 5 years, I think people are going to, most people are going to get one, and then generally people who are able to take advantage of the capabilities of these things are going to want they're going to want quite a few more than just one. I think we're going to see a very goofy looking distribution of numbers of printers that somebody has, because once you've decided you want one of these or two, more than one of these things, suddenly N of these things become, all of the potential situations where they would be useful start appearing to you. And
the early adopters, the early adopters are going to basically do the same thing that the homebrew company or homebrew organization did in Silicon Valley in the 90s and stuff, or 80s and 90s, where Steve Jobs and what's his name met. So they're going to just fuck around with a lot of different bunch of stuff, but then a lot of that stuff will be incorporated into models that will incorporate all those activities into one model, basically. So yeah, go for it.
Kind of. I would say that so part of what's going on here is that with bits kind of eating atoms, what you end up with is an imposition of a lot of assumptions about the world that that come from software onto the world of manufactured hardware, and one of those is that you're going to have a lot of open source stuff. So I expect, based on our experience with the open source system, that instead of centralization and standardization on any single thing, there will likely end up being there may be things that are like the very clear winner in their category, like the Linux kernel over everything else, but those things will just be pluggable parts within a larger system of adapters and pieces of equipment that can allow stuff to work together. So it's important to not think of this stuff as a single system of manufacturing, but rather as a shift in how systems of manufacturing are organized, and a proliferation in systems of manufacturing that are nevertheless more interoperable than ever before, purely by the nature of how they're configured.
That is going to take me a bit to wrap my head around and turn that into something I can riff off of. Go for it. Mm-hmm.
Well, a real world example of this is what's happened in Shenzhen, right? So, what we're doing at GenFab, we consider to be, we say this kind of tongue in cheekily, particularly when we're talking to DC type people. We are facilitating something of a technology transfer from the folks in southern China, right? There have been some things that the people in Shenzhen, who frankly I would love to continue doing business with, if they would just get rid of their horrible government. Yeah. There are a lot of people there who have figured out how to do how to live in prototype world permanently and still make money on it, and how to scale out manufacturing very, very effectively and very quickly. And with economic assumptions that are totally different than what we have here in the United States. There are lots and lots of firms there that just do one or two or three things. They standardize around various different components, and then 2 or 3 years later the standards change, and then very dynamically all of these firms reconfigure themselves and are on to making other stuff. we think that sort of market logic is likely going to pop up in a few different clusters in the United States, and
this is
facilitate some of that.
This is the thing I've been trying to wrap my head around, is because the domination of China right now in terms of manufacturing looks complete. It's like winter is coming, kind of thing. It looks like that winter is coming, and the amount of leverage that China could have on the globe right now, it looks like it's almost unstoppable. But that's just like a fear-based thing as well, because China has its own issues, but I'm like, my question is, how can we in the world, because I just got back from Brazil, and Brazil is under the thumb of China, under the influence of China. The United States has a lot of influence now in China, Africa, Europe itself. Europe just kind of, with the pandemic, their version of the lockdowns, like no change whatsoever, or no potential for different models. Even Sweden now has laws that have been changed that allow for the lockdown model to basically take over. So I'm like, how does the world kind of change? It looks like what you're talking about might offer, as long as it happens on a time scale that's in the next, like 5 to 10 years, essentially, how to decentralize manufacturing. What do you think of that?
Yeah. I mean, look, I think there are changes in social systems that are going to drive smaller and smaller jurisdictions, to greater and greater levels of importance. I think that we're going to probably see a lot of polities at the level below states emerge, not necessarily geographically linked, but essentially just like a bunch of people who are united by their use of a shared set of systems and by their affiliation with a given, set of convictions. Right.
Yeah.
And I think that we're going to see, as, culture war stuff keeps going and as international pressures keep ratcheting up, I think it's likely that we'll see a lot of, a lot of people place a really high priority on the ability to live, autonomously with respect to large industrial systems of control. And I think that we see ourselves as very supportive of like small group autonomy. And we want to build systems, maybe not for, maybe not at the level of the individual family, but definitely at the level of of like a Dunbar count community.
Yeah.
And definitely at the level of, cities, regions, that sort of thing. We think that that's, roughly the appropriate level of scale for small, medium, and large fab facilities. You're going to have 1 or 2 in the home, 100 or 200 in your community, provided by your local co-op or by some 7-Eleven, but for random plastic parts. Modes of organization will vary, right? But you'll see that scale, and then you'll also see specialist production at large scale, provided through the increasingly sophisticated 2-day shipping system, and other things like that. It's gonna, a lot of people really don't like the idea of a just-in-time economy, but the reason they don't like the idea of a just-in-time economy is that the just-in-time is usually dependent on something moving across an ocean. And if you can just-in-time something out of filament you already have sitting somewhere and out of wires and
it's magic.
It just means that you want a given part or object or whatever, and it can show up in 3 days.
Typically.
And
this gets into something that I've been thinking about since we started talking, which is essentially we've got this world in front of us that we see with our eyes and that we can touch with our senses, and it's all kind of related to evolutionarily what we want. And tools, being tool users, we've always had this like it's always about the tools. And
we are tool building apes, yes.
And so like we get off on this like deep level, and these tools allow us to change that reality that I see, basically. So I can cut down that tree, I can remodel this thing, and so that is basically going to the constraints of that are about to change in this really significant way. So not only are we going to be able to retool the tools we have already and build new ones, but then there will be new things that will come out of this that we couldn't have even foreseen. For example, like an example would be Facebook. Like nobody thought that social media was this thing that would take over the world. Like nobody saw that coming, and MySpace kind of saw that coming, but nobody really took it seriously. It was just a way to share photos and connect with friends and stuff like that. Now it's this way that's kind of moving elections and changing the nature of what we think is reality. So it's going to be interesting to understand what was there anything that came to mind of like, but so how do I make that grounded in a tool? We've already talked about a little bit with the woodworking and the jibs and stuff like that. And this idea, I like this idea of a small 7-Eleven that's just made for manufacturing stuff, and that model already exists in Africa for solar power and for water and all these other things. As you go to this other thing, and then they'll just create this magic stuff. Anything come up for you in that my listeners would find value?
At the scale of like businesses they could start?
Oh, well, interesting. Businesses,
is that what you mean?
Just businesses, homesteaders. How will this change the nature of objective reality for people in this?
Well, some of the first people to take advantage of this, and I'm about to enter shameless pitch territory, so buyer beware. But some of the first people who are going to be able to take advantage of this kind of thing will be anybody who has a really good understanding of like a market niche. One thing that we've been messing around with a lot lately, just because they require a lot of plastic to make, and that means that we get to run a lot of plastic through our machines, and that means we get to a lot more benchmarking data, and we like benchmarking data. So one of the things we've been experimenting with, to satisfy that set of needs, and then also just have something that we can kind of hand off that's useful to people, is making climbing holds. And these things are oftentimes like $85 for a 4-pack or something absolutely ridiculous like that. And we can make these things for it's going to depend on the filament, so I can't really give a very big number, but a very clear number. But let's just say it's at least a third, probably usually like a sixth of the actual cost of molded climbing holds. And unlike molded climbing holds, we can do arbitrarily complex, and oftentimes something we're looking at that would be applicable here is procedural generation. We can do we can do any sort of different hold and any sort of different texture on a hold, with no marginal tooling cost. Whereas somebody who has to go, or who wants to go make like a very specialized sort of like training hold, like a foot placement training hold, they're going to have to go through the whole process of like molding it and talking with the company that designs molds, and doing some months-long DFM process in some cases, and we just aren't subject to those constraints. We can look at an interesting rock, scan it, and print it, and have it up on a wall in 12 hours.
But so anyone
who's familiar with like a comparable niche like that, whether in photography or shooting or, you know, or cross country skiing or what have you, that those are the people who I think can experience interesting things related to this, you know, this cost collapse in, you know, in machine tools. So if you're a creative person with a set of product ideas around that, come and hit me up because I want to sell you a bunch of equipment. But yeah, I mean, that's how I think a lot of people are going to experience this at first. I think they're going to see it on their Instagrams. You know, the people in the various different hobbies and things they're into are suddenly going to start showing up with all manner of custom and oftentimes like electronics integrated equipment. And
that'll go into the influencer model where it's like, you know, we're already seeing it with NFTs where, you know, if you already have a large people who are interested in what you have to offer, it's just like the sky's the limit in terms of the creativity, access to that. And yeah. And art seems like it's a big one. Have you seen people making 3D printed art?
I have seen everything from I've seen everything from like what you would very easily call like fine sculpture, like actual attempts to create genuinely impressive, like some sort of thing you would stick in a museum and a bunch of people in turtlenecks would go like, interesting. You know, that there have been serious swings and I think actual connections on that. I think that so I think there's a bunch of stuff that is possible in the artistic domain there, and I think that things that are perhaps a little bit more lowbrow are, you know, like all manner of cosplay stuff. Like this, 3D printers have taken over that market. So very quickly,
that, like maybe, you know, somebody wants to go duel with somebody and they can, you know, 3D print like a multi-pronged sword.
Exactly. If you are the sort of person who likes to dress up like ridiculous video game characters, 3D printers are fantastic because you can print yourself like a Master Chief, you know, like battle suit from Halo, or all, you know, all manner of the furry community loves these things and is in very deep. And if there's any group of people who are interested in small group autonomy and the ability to produce things that are generally frowned upon by the larger supply chain, it's furries. And believe me, anything that group of people adopts, take a very close look at because it's probably a really good idea.
Yeah.
And those folks are into this sort of like fabrication technology stuff with both feet and tail. So
let's get back into the fundamentals of it too, because there's the filament, and then when you were saying that about the swords or whatever, the idea, or no, is the rock wall, like the size of it as well, the size of whatever you're trying to produce. What are the size constraints and what are the filament constraints?
So the filament constraints are typically related to temperature and to build chamber environment. We're going to shoot for so our first printer is called Tracer, and we're on V0 of that. We're calling it that because the hot end that we're eventually going to put on this looks like a fountain pen. It's kind of neat. I think people are going to love what it looks like when it finally comes out. But anyway, that is going to operate mainly at the like 60 to 90 degree centigrade level in terms of build environment, and it's going to have capabilities on the hot end itself to get up to say, you know, like 350, 400, while still being able to, degrees centigrade, while still being able to operate, operate in a reliable fashion. what this allows is a capability envelope that covers a lot of materials that weren't previously available to people at operating at relatively small scales, or available to people who didn't have a $50,000 Stratasys 3D printer, right? So that means polycarbonate, nylon, all sorts of different carbon fiber doped materials, lots of interesting stuff with continuous carbon fiber, other things along those lines. So that's sort of if I'm understanding your question correctly, that's sort of where the general capability envelope looks like. And then filaments are just produced at a sort of commodity but custom scale, I guess. There aren't that many changes in your processes you need to make to string different types of filament. You essentially just need to be able to melt and extrude plastic, and keep it in an environment where the plastic is in relatively good condition. So dry and room temperature typically. So that's sort of how that industry is configured. I expect to see a commodification of both, both printers and also filament production.
Yeah, and then the size thing. The size. If I'm just got one of these things in my backyard or in my garage, and it's kept at room temperature, what is the limit of the size that I can build?
So I would be surprised if anyone would find a printer larger than a washing machine useful in their house. We will have printers eventually, and the DoD makes printers, the DOE, Department of Energy, makes 3D printers that are capable of doing like medium-sized boats in 12 hours. So that sort of like macro scale 3D printing is definitely something that's coming down the pike. We might not do that a whole lot, but there will be, we will have counterparts in industry that do that and are going to be able to do it really well. Yeah.
Interesting.
The size constraints are primarily process limited. If you're doing small nozzle filament deposit modeling, FDM printing, which is what most people think of as 3D printing, then generally like you're restricted in practical terms right now down to about a meter cubed build space. We expect that to grow, but there's also like human beings are, generally speaking, you don't really need a budget for any more than about 2.5 meters of vertical space, and that means most objects we use are no longer than that.
Interesting. So for this last 5 minutes or so, there, if I'm a homesteader, or if I'm a homesteader, or if I'm actually just in a city and I want to start experimenting with this different type of stuff, what are the main 3 things that I need to do in order to get myself up and running in a month or so?
Well, we have a really strong interest in helping people do that, and for that reason, I don't want to give you a specific set of things to do right now, because it's going to change relatively soon. Or my advice on this is going to change relatively soon, because we're literally going to be rolling out a bunch of products that are designed to help people bootstrap into this very quickly, in much the same way that Stripe makes it really easy for people to plug into the payment system. So we think right now the best thing, if you're interested in working with this or just having one of these things to use around, I would say learn CAD.
Yeah, that's it. Okay.
That's currently And that's a big ask because CAD is primarily a Windows only thing. It is designed with a lot of really, I would call 20th century assumptions. It's just not like modern software. It's good for what it does, but like there's only one prominent like browser delivered CAD product, and it's called Onshape. We use a combination of Autodesk products and Libre products, with a strong preference for Libre when we can get away with using that. So yeah, definitely learn CAD. If you want to play around with a hobbyist printer, that will be able to do everything kind of up to the top range of like toy, the Ender 3 is fantastic. And there are a lot of people who use it for non-toy applications. I want to be clear about that. Like there's an entire 3D printed firearm community that uses the Ender 3 to do some incredibly technically impressive stuff in terms of containing explosions in a controlled fashion. You know what I mean? It's an incredible physics problem, and I would suggest everybody take a look at that. They're kind of testing the limits of hobbyist 3D printing, and we think that we can kind of raise that whole standard by quite a bit by just opening up a much larger material envelope and a much better tooling envelope for people, delivering a much better toolbox for people. On the software side particularly too. So
so that's what I was going into, or I wanted to go into, is that essentially it seems like the software is really the main blocker for getting into consumer mindset, because what you just said about the CAD modeling was like, I don't want to do that.
It's a huge pain in the ass.
Yeah. So you guys are going to develop software as well for this.
We already have cobbled together and extended a bunch of open source systems. We intend to keep most of our publicly available software output open source. We will likely deliver, like there are going to be certain things that you can't do in CAD, or that you, or there are going to be certain things that you can't do on your own CAD, right? Or your own desktop or what have you, things that are more efficiently done at the scale of big computing farms. And that's the world that I come from, and several other people on our team come from. We're software engineers, and we're very familiar with deploying very large scale applications very quickly, and deploying the servers also that are needed to go do that sort of thing. So we will likely sell access to anything that is more efficiently done on a supercomputer than on your computer. And we will also have a bunch of different factory management systems that will likely keep proprietary. But, oftentimes I think we'll find it useful to actually just give people access to some of that stuff as well, if it means that we can, integrate into their system as a partner. We're looking to reduce a lot of the upstream complexity for people. We don't want this to be as big of a pain in the butt as it is to get into right now. And we think that, there's an enormous amount of just economic potential currently locked up, because the start costs for a factory right now are, like $1.5 million, if not quite a bit more than that, depending on what you want to do. We want to drop that number considerably. And we think
seems like you guys should talk to Meow Wolf. You should both talk to Meow Wolf. The people, do you know what Meow Wolf is?
No, I'm not familiar.
So Meow Wolf is it's like Disneyland meets Burning Man on psychedelics. So it's an actual physical space where they've created a Disneyland type of environment, heavily influenced by the psychedelic stuff. So, and they've got 3 of them now. There's one in Santa Fe, New Mexico. They're building one in Denver, and they just opened one in Las Vegas. And these guys are like the opposite of startup world. It's a bunch of artists who are basically an artist collective making art out of trash for 8 years until they opened up this thing, and it's become a sensation. So I would talk to the management there, but they had to let go of a lot of people, the original core, because of the pandemic, and all those people are walking. Yeah, well, and they're walking around with CAD knowledge because they were doing a bunch of that stuff. Yeah. And so, and just like brilliantly creative people who were all making art, and as I imagine are still making art, and they would go in on this stuff. And there was something else that they had. I kept on asking them if they were using 3D printers, and they were like, no, most of our stuff is being done with. Oh man, it's been so long. It's like some other manufacturing thing that came around in the last few years. This was 2 years ago, 3 years ago. So I can't remember.
I'd be curious to hear what that is.
Yeah.
This looks really neat though. I'm paging through their site. This is pretty cool.
Yeah, I would talk to them.
Anyone who's doing that sort of like large scale art installation. Yeah. I mean, oh my God. Yeah. I have a million different ideas for you, particularly about like embedded electronics stuff. Yeah.
Oh,
like
I know,
get at me, if you're listening to this and you do Burning Man type, like large art installation stuff, please drop me a line. I am more than happy to help you facilitate some very cool shit.
How can they get in touch with you?
So I'm usually pretty available across the various different social platforms that matter. At this point, that's just Twitter and Clubhouse, and so I mean, everything else is kind of falling apart. I'm also on Mastodon, Shelling Point. You can find me just at Matt Parlmer, MattParlmer. You can find GenFab on Twitter as at GenFabCo. Sign up for our blog. We're currently waiting on the government to give us the thumbs up that we can operate and sell stuff. And, there's a lot of back and forth going on right now, and a lot of, the paperwork 2-step. But we'll be in a position to actually move product hopefully pretty soon here. And we're going to build a queue of alpha testers that we think will be really well served by this set of systems that we're building out. And it's our hope that we can essentially just help democratize the means of production at least a little bit, or contribute in some small way to that effort. And we think that it's important to give people the tools to build a better future. So if that's something that, if that set of tools is something you need, reach out, talk to me.
Thank you so much, Matt.
Yeah, Stuart, this was awesome. Thanks for having me on, man.